Hello everyone, my name is Aditya Tiwari, Assistant Professor, CSVTU, Bhilai. In this tutorial, we discuss about binary searching. So, binary searching comes under the searching. As you know, searching is an important factor or basic main operation of data structure. Searching, when you want to find any element inside the data structure, at that time you require a searching operation. Via searching, we can update your database also. So, when you're performing insertion or deletion operation, when you go for the insertion operation, you have to find out the location where that particular item will be, in which location the item will be situated. And particularly when you want to delete any data from the database, you have to find out that particular element is available or not. For that purpose, we required, or we can say for the updating of the database, we required one important operation that is called a searching operation. Searching is the process of finding some particular elements in the list. If the elements is present in the list, then the process is called successful. With the help of pointer, one by one you can, by the operation you can search an element inside the list. And the process return the location where the item is situated. Location of that element, that is called a successful operation. Otherwise, the search is called a unsuccessful. Suppose item is not present in the list and your pointer will be started from the beginning position and run to the end position, and item is not available in that particular list. So, you can say your searching is unsuccessful, or we can say the failure of operations. So, there are two popular search methods that are widely used in order to search some items into the list. However, choice of the algorithm depends upon the arrangement of the list. The first algorithm is a linear search and the second operation is a binary search. Linear search we already covered in the previous tutorials. So, today we discuss about the binary search. So, binary search is the search technique which works efficiently on the sorted list. This is an important keyword. When you performing a searching operation inside the binary search, the list should be sorted. If list is not sorted, binary search will not work. So, before you performing this operation, you have to sorted the list either in ascending order, either in descending order. Hence, in order to search an element into some list by using binary search technique, we must ensure that the list is sorted. Binary search follows divide and conquer approach, in which the list is divided into two halves and the items is compared with the middle element of the list. If the match is found, then the location of middle element is returned. Otherwise, we search into either of the half depending upon the result produced through the match. We can see later on we are talking about the which half, either a below half or the upper half. So, binary search algorithm finds a given elements in a list of the elements with O of log n time complexity, where n is total number of elements in the list. The binary search algorithm can be used with only a sorted list of elements. That means the binary search is used only with the list of elements that are already arranged in an order. The binary search cannot be used for a list of elements arranged in random order. This search process start comparing the search elements with the middle elements in the list. If both are matched, then the result is element found. Otherwise, we check whether the search element is smaller or a larger than the middle element in the list. If the search element is smaller, then we repeat the same process for the left sublist of the middle elements, or we can say below sublist of the middle element. If the search element is larger, then we repeat the same process for the right sublist of the middle element, or we can say the upper sublist of the middle element. We repeat this process until we find the search element in the list, or until we left with a sublist of only one elements. And if that elements also doesn't match with the search element, then the result is elements not found in the list. That is a message will be generated by the compiler. So now we start binary search. How we implement the binary search? So we can see the following steps. Step number 1, read the search element from the user. Suppose you are having a list. If you are talking about your contact list, a mobile contact list, and I give you some instruction, find out the name which is available in your mobile list is available or not. So go for the first step, read the search element from the user. So I am a user, I give you instruction, search this element. In step 2, find the middle element in the sorted list. So with the help of formula, we will discuss the formula. So first we go for find out the middle position of that particular list, and we can check the element. That particular element will be compared with the requirement element. If it is matching, so we can say the successful, otherwise not successful. So go for the step number 3, compare the search element with the middle elements in the sorted list. In the step number 4, if both are matched, then display given element is found. So this is a message. Suppose what we want to search, already we will execute it in the middle position, we can find out the middle position. So we can say right now one message, given element is found, and terminated the function. We can't go for the rest of the operation. If we find out our task is successful, we stop the operation and directly we exit from the algorithm. Suppose item is not found in the middle of the position, so we go for the step number 5 step. If both are not matched, then check whether the search element is smaller or larger than the middle elements. So in step number 6, if the search element is smaller than middle element, repeat step 2, 3, 4 and 5 for the left sublist of the middle element. In step number 6, if the search element is larger than middle element, repeat same steps 2, 3, 4 and 5 for the right sublist of the middle element. Now go for the step number 8. Repeat the same process until we find these search elements in the list, or until sublist contains only one element. Now go for the next step. If that element also doesn't match with the search element, then display elements is not found in the list, and terminate the function. So when the operation will be started, the pointer will be started from the beginning to the end and exit the end position, and element is not found in the list. So you can write the one message that particular element is not found in the list. So by this steps, either operation is successful or we can say operation is unsuccessful. So by this example, we can understand how we search an element. Here I taking an array, I take the array and insert some elements like 1, 5, 7, 8, 13, 19, 20, 23 and 29. So starting from the beginning end, that is a array indexing starting from 0, and the last element will be stored at the 8th position. So I fix the pointer, first is beginning and the end. Beginning should be fixed at the first indexing position of array, and end should be fixed at the last position of the array, or the nth element of the array. By the fixing of that element, now we calculate the middle position. So here we having the first step, already we done, beginning we set, end will set at the 8th position. Now find out the middle position. So by the operation middle equal to integer beginning plus end by 2. That means 0 plus 8 by 2. It means 8 by 2 is 4. So middle position will be fixed at the by the operation is 4. So when 4 will be middle position will be find out. So we check the data of array of 4. So array of mid equal to 13. Then we go for the comparing operation. 13 is not matched with the requirement item, that is suppose I want to search, here is a 23 item I want to search. Now after we executing the middle position, the middle position is a of 4 and the fourth location having a data is 13, which is less than the 23. Here 23 I want to search 23 item in the given list. So item is not matched, and also we compare that particular item. So item is greater than the middle position data. So therefore in second step the pointer will be updated. If the item is greater, searching item is greater as compared to the middle position, so the beginning pointer will be updated with the help of beginning equal to mid plus 1. Already we know by the mid operation, we understand the mid data is less than the searching data. The obviously the below list of the mid list, beginning to mid list item, all of the items are the smaller as compared to that particular searching item. So we update the beginning position from a beginning to a middle plus 1. It means now our beginning pointer will be reset at the location of 5. Now end position as it is, we can't update that one because the item is might be possible in between duration of 5 to the 8th position. Now again we calculate the middle position with the help of same pointer address, like that 5 plus 8 it means 13, 13 by 2 it means a 6. Check the data of a of 6. Here we having a of 6 is a 20. So again we compare with the searching item. Here searching item is again 23. When we compare with the 20, so 20 is less than 23. So again therefore we can say 23 is greater than 20. Again we reset the again pointer. It means again item is not matched, so again we reset the pointer, and the pointer will be resetted from beginning, again beginning from jump from 5 to again 7, like that, because the middle position that is called as 6, that is a item is not available at there. It means beginning will be updated from 5 to 7. So now data might be available in between 7 and 8. Now with the help of same operation, again we go for that one. Beginning, now the beginning pointer will be set as a 7th position and end pointer will be not updated, is same situated at the same position at the 8th position. Again with the help of middle position, 7 plus 8 it means 15, and we divided 15 by 2, that is called a 7.5. It means we take an integer value only as 7. So a of 7, we check the data of a of 7. Here we having a of 7 data is 23. When we comparing with the searching item, 23 will be matched with the 23. So we can write the message, now item will be found and the operation is successful, and directly we locate the address of that particular data where the data is available in the list. This is a way to find out the item in a list using a binary search algorithm. This is our first way. There are 3 basic type of approaches: worst case, best case, and the average case. Suppose you find out data elements like 13. So by the help of same pointer beginning and end, when you find out the middle position, and the middle position by the first operation, that is the a of 4, and the 13 is a searching item, and the first case 13 searching item will be equal to the a of 4 item. So you can say that's the best case of your journey of the searching that particular item. Suppose here we find out the 23, by the couple of operation you can get the data. It means you can say the average case or the worst case of this particular binary search algorithm. So this is a way to how to fetch the item from a binary search tree. We take another example. Suppose you find out the 5 from the given list. Now again you find out the mid item, mid value, that is a of 4, with the help of same operation, beginning equal to 0 and end equal to 8. So again find out the middle position. Again you get check the data that it is 13 and your searching item is 5. 5 is less than 13. Now in this case the end pointer will be updated. Beginning pointer will not updated, located at the same position 0, but the end pointer will be updated by the mid minus 1. Now again you cross check the data, searching data in between beginning to mid minus 1, that is the pointer will be reset the end pointer, that is mid minus 1. So again you cross check, then again you find out the middle position, again you compare with that one, then you find out the data will be available in the list or the not. So what we done in the previous one, we update the beginning pointer. When the item is lesser than the middle position, so here you update the end pointer, you can't go update the beginning pointer. This is a vice versa operation. By this operation you can find out the data will be available or not. If both the pointer are holding the same position, the one case also available, both the pointer are holding the same position, and that after that maybe you get the data or may not be. If you don't get the data, and the pointer will be updated, beginning will be exceeded from the end pointer, so you can say data is not available inside the list. So that is an unsuccessful operation. So we go for the pseudocodes. So I hope understand the concept of binary search with the help of this example. Now how we write the pseudocodes. So we are giving an input array that is supposed to be stored in the ascending order. We take two variables which will act as a pointer. It means beginnings and end pointer. There are two pointers that are really required. The first is a beginning. We can write as a BEG in the form of beginning and END in the form of end operation. Also we require another operator that is called a middle, but middle will be generated with the help of beginning and end. So before we generating a middle, we have to fix a two pointer beginning and end at the position. So beginning will be assigned with the indexing 0 and the end will be assigned to the last index of the array. Now we will introduce another variable mid which will mark the middle of the current array. That will be computed as low integer of low plus high by 2. So it means we can say the beginning position plus the last end position by 2, and what we get the result it should be in the integer form. If the element present at the middle or mid of index is equal to the element to be searched, then just return the mid index. If the element to be searched is smaller than the element present at the mid of index, move and to mid minus 1. And all RHS will be discarded. You can't go for the operation to searching operation at the RHS of the middle position, because by the middle of the data you can find out that data is not be available at the right hand side of the middle position. So you have to discard that particular list, sub list of right hand side. If the element to be searched is greater than the element present at the mid index, move beginning to mid plus 1. Here you discard all the LHS data. So LHS data will be discarded. It means we definitely item should be available the RHS of the middle position. Item is not available in the LHS of the middle position, so you have to discard the list of sub list of LHS. So for this implementation, we can write some codes like binary search algorithm. We can write the binary search algorithm by the two approaches. First is interactive approach. In an interactive approach, binary search, inside the parameter you can write array and size. You applied the loop until big is not equal to the end. If a beginning is equal to end, it means the last operation. If that exceed that one, the operation will be stopped. So you have to find out the mid of index by the calculating the integer of beginning plus end by 2. If item equal to array of mid index, so you can write, if the item is already matched, you can write return mid of index. Otherwise item, you have to compare the item either a greater or the lesser. So you put the symbol if item is greater than array of mid of index. So here you update the beginning pointer with the help of mid index plus 1. Otherwise, end pointer will be updated with the help of mid index minus 1. So when you searching any item, item will be matched at the middle position, you can't update any pointer. But if item is less than or greater than, you have to update the beginning or either a end pointer as per the situation or as per the condition. Another approach is a recursive approach. So in a binary search, again we required some parameters like array, items, beginning or end pointers. If beginning is less than or equal to end, so we directly find out the mid of index. So by the mid of index, we find out integer beginning plus end by 2. If item equal to array of mid of index, so return mid of index. Else, if item is less than array of mid of index, return binary search. Again inside the parameters write array items mid index plus 1 and end. Here we are updating our beginning pointer with the help of mid index plus 1. Else, suppose item is be the left sublist, here we are updating return binary search array item beginning mid index minus 1. Here we are updating the end pointer with the help of mid of index. So again return minus 1. So again in a binary, you can write directly pseudocodes of binary search in an examination point of view. So binary search inside the parameter like a lower bound, upper bound, or we can say value. In a step number 1, set initialize set beginning equal to lower bound and end equal to upper bound and should be position equal to minus 1. Here we don't know the position of where the particular data what you want to search item in which position will be holding. So initially you put the position equal to minus 1. In the step number 2, repeat step 3 and 4 while beginning is less than or equal to end. In step 3, set mid equal to integer beginning plus end by 2 by the calculating this one. In the step number 4, if a of mid equal to value, set position equal to mid, print position and go to step number 6, it means the exit. Otherwise, else if a of mid is greater than value, set end equal to mid minus 1, else set beginning equal to mid plus 1. So end of if structure, end of loop. And finally, step number 5, if after executing all these steps, if position is not be reset and the position will be again a minus 1. So you can directly print a one message, value is not present in the array. So we directly end off if structure and finally exit, either we either operation is successful, either unsuccessful. So this is a pseudocode you can write in the examination. So why this sometimes in a examination point of view, write this code of the binary search program using recursion like that. So we can take a simple example using a C programming. So here we take a header file, include studio.h, then we take a integer binary search and we take some parameters integer. So we have to fix a beginning pointer, end pointer and lot of the pointer. So for that we required some integers values, and so then we start our program like in a void main. As you know that the main is a user defined function, the void is used for the no return data type. Then you start this structure int of array. If here we pass the value of array of size, here we pass the value 10, it means 10 data should be stored in the array, and pass the values like 16, 19, 20, 23, 45, 56, 78, 90, 96, 100. And initially int item also take and location equal to minus 1. So before we starting the searching, location should be a minus 1. So start either printf inside the strings, enter the item which you want to search, and the scanf, the %d and the % of item which you want to search, the location equal to binary search inside the parameter array 0, 9 up to 0 to 9 and item. So indexing is starting from the 0 and the end is the 9th position, and find out the item which we want to search from the list. If location is not equal to minus 1, it means printf item found at location and display the address of that particular address of the indexing list where the item is available with the help of %d, the location. Else item not found, and if item is not found, the int binary is such int a beginning and int item, if int mid, if and is greater than or equal to big, then start this structure. You have to calculate the mid position with the help of integer beginning plus end by 2. If a of mid equal to item, then return mid plus 1, because indexing is starting from 0. That's why if you get the data at the mid position, you have to write the mid plus 1, the indexing number where the item is located. Else if a of mid is less than item, return to binary search a mid plus 1 and items. Else return binary search a beginning mid minus 1 item. So the two cases, either you get the data. If you get the data, either mid of position is equal to the item, either you comparing with one. So either mid pointer will be, beginning pointer will be updated, or the end pointer will be updated by this structure. So when you don't get the data, so directly return -1. So when suppose in this example, enter you want to search some item. Here you want to search 19. And 19 is available in the list or not? Yes, 19 is available in the list. By this execution, you have to find item found at the location 2. 2 is indexing number where the item is available in the form of 19. Now, binary search time complexity. In each iteration, the search space is getting divided by 2. That means that in the current iteration, you have to deal with half of the previous iteration array. And the above steps continues till beginning is less than end. Best case could be the case where the first mid value get matched to the element to be searched. There are 3 type of cases. First is the best time complexity, that is O of 1. If you find also as searching operation and get the result in the first operation, that is the best case complexity. Average case, it means O of log n, and the worst case is also same as O of log n. So there are 3 kind of possibility: best, average and worst cases of time complexity. Sometime in examination point of view, an interview position point of view, the interviewer will be asked or examination will be asked calculating the time complexity of binary search. So you can easily calculate the time complexity. Take one example like that. Let k be the number of iteration. Example, if the binary search gets terminated after 4 iteration, then should be k value of k equal to 4. In a binary search algorithm, the array taken gets divided by half at every iteration. If n is the length of the array at the first iteration, then at the second iteration, the length of the array will be n by 2. Again, dividing by half in the third iteration will make the array length n by 2 by 2. So we can directly write one expression, n by 2 to the power k. In this form, we can generate any values. Similarly, at the fourth iteration, the value of the array length will be n by 2 to the power 3, or we can say 2 to the power k, and so on. So at the kth iteration, the value of the length of the array will be n by 2 to the power k. So 2 to the power k should be in denominator, and numerator is a n. As after k division, the length of the array become 1. Therefore, we can say n by 2 to the power k equal to 1. So calculate this one. So n equal to 2 to the power k. So applying log function of both sides, log n equal to log of 2 to the power k. It means log with base 2. So log n equal to k log 2 log with base 2, as log a equal to 1 log with base 2. So therefore, we can write k equal to log base 2 n. So therefore, the time complexity of the binary search algorithm is log of base 2 n. So this is a way to find out the time complexity. So now go for the next complexity is as binary search space complexity. So no auxiliary space is required in binary search implementation. The binary search algorithm's space complexity depends on the way the algorithm has been implemented. Two ways in which it can be implemented are, first one is iterative method. In this method, the iteration are controlled through looping conditions. The space complexity of binary search in the iterative method is O of 1. In the second method, that is the recursive method, in this method there is no loop and the new values are passed to the next recursion of the loop. Here the maximum and a minimum value are used as the boundary condition. The space complexity of binary search in the recursive method is O of log n. So we can easily write the complexity. In the most of the examination, you have to, in a competitive examination, you ask the complexity of binary search. We can calculate the complexity by the performance. So there are three kind of performance, are the worst case, best case and average case of the time complexity. And the worst case complexity is O of log n. Average case complexity is O of log n, but the best case time complexity is O of 1. We are talking about the space complexity. So in all the cases we having a O of 1 is a space complex, because no any auxiliary storage will be required for the binary search algorithm. So advantages of binary search algorithm, since it follows the technique to eliminate half of the array elements, it is more efficient as compared to linear search for the large data. Better time complexity and thus takes less computation time, and an improvement over linear search as it breaks the array down in half rather than sequentially traversing through the array elements. These three advantages of binary search algorithm. We also discussed the limitation of binary search, like binary search algorithm could only be implemented over a sorted array. Small unsorted arrays would take considerate time in sorting and then searching the desired elements. So binary search is not preferred in such cases. It has poor locality of reference compared to linear search algorithm when comes to in memory searching for short intervals. These are the limitation of binary search algorithm. And finally, the application of binary search are, this algorithm is used to search element in a given sorted array with more efficiency. It could also be used for a few other additional operations, like to find the smallest element in the array or to find the largest element in the array. These are the two applications of binary search. So in this tutorial, I hope you understand the concept of the binary search algorithm, how we create a list, how we perform the operation, and what is the main use of this application in a data structure operation. So, what is the tutorial? Thank you.